Hello, in this video we are going to see some basics of the coaxial cable, like whether our coaxial cable can carry higher frequencies, what is the dominant mode of propagation in the coaxial cable, and what are the basic equations in coaxial cable. So let's see that. So if you consider a coaxial cable, this is the basic structure. It will be having an inner conductor which is surrounded by the dielectric insulator, which is again surrounded by a metallic shielding, and which is again covered by a plastic jacket. So this is the cross-sectional view of the coaxial cable. So this is the inner conductor which is surrounded by the dielectric, and this is the metallic shield. This one is the metallic shield, and di is the diameter of the inner conductor, and d0 is the outer diameter of this dielectric layer. So this is the outer diameter of this dielectric layer. The dominant mode of propagation in coaxial cable is TEM. So let's see how this is happening. So if you see the electric field inside the coaxial cable, you can see that electric field are from the inner conductor to the outer conductor. So this is an animation showing how the electric field is varying from the inner conductor to outer conductor. As this coaxial cable is a cylindrical structure, here I have considered a cylindrical coordinate system. So here you can see that electric field is along the rho direction. So this is how the electric field is changing. And next, see the magnetic field. So if you consider here, you can see that the magnetic field is forming the circles around the inner conductor. So this is the animation. Here you can see how the magnetic field is varying. So that means that the magnetic field is varying along this axis represented by the psi. So the electric field is along the rho axis and the magnetic field is along the psi axis. Next, we can see how the propagation is inside the coaxial cable. So here you can see that the propagation, so this is the direction of the arrow. Here you can see that propagation is along the Z axis. So here we can see that the coaxial cable propagation is TEM because the electric field, magnetic field, and the direction of propagations are perpendicular to each other. So the dominant mode in coaxial cable is TEM mode. So let's analyze some of the basics of the coaxial cable. First one is the characteristic impedance, because we know that the characteristic impedance is one of the important parameter when we are dealing with the RF designs, and we usually go for 50 ohm characteristic impedance. So the characteristic impedance of the coaxial cable is given by the expression ln d0 by di by 2 pi into eta, where eta is the intrinsic impedance, and it can be given by the expression square root of mu by epsilon, or in other words, it can be given by 377 by square root of epsilon r, where 377 is the impedance of the free space. In terms of the log 10, this expression can be also given by the expression 138 by square root of epsilon r log 10 of d0 by di. Here you can see that the characteristic impedance is depending mainly on these d0 and di, that is these diameter parameters. So it is like if you can maintain these ratio, you can change the dimension, means you can change the coaxial cable, like you can taper or expand it to have the characteristic impedance having the same characteristic impedance like Z0. That is one of the important characteristics of the coaxial cable. Next, let's see what is the phase velocity, because we know that this coaxial cable contains some dielectric. It will be having some phase velocity, and it can be given by the expression c by square root of epsilon r, because this phase velocity mainly depend upon this dielectric parameter. So this does not have any um, dependency to the diameters like di or d0. That means that if the cable is thin or thick as the pipe, the signal travels the same speed if this material used in both the cables is same. That is, the phase velocity only depends upon this material parameter. Next, we have seen that in coaxial cable, the dominant mode of propagation is TE, but one of the main important characteristic is it has some cutoff frequency. So the coaxial cable will be supporting TEM mode of propagation up to the cutoff frequency. After the cutoff frequency, there will be some higher order modes like TE11. So this will be occurring when the wavelength is comparable to the circumference of the cable. So when that happens, instead of TEM mode, the higher mode will also starts to propagate. So that cutoff frequency can be given by Vp by pi into D0 plus Di by 2 because it depends upon these parameter, the physical dimension of the cable. So when this occurs, like when you have this cutoff frequency, the different modes will be traveling at different speeds and can cause the signal distortion. So the coaxial cable can be used up to the cutoff frequency. After the cutoff frequency, it will be having the higher modes of operation. So here you can see that the cutoff frequency is inversely proportional to the diameter. So if this diameter is very small, it will be having very high cutoff frequency. But if the diameter is very less, like if we are going to use the very thin cable, you will be having higher cutoff frequency. But you can see here that if you have the very thin dielectric, you will be having the characteristic impedance is a zero given by this expression. And okay, so let's see what are the advantages and disadvantages. As this coaxial cable is shielded by a metallic covering, it will be having the good shielding capabilities and it is free from external electromagnetic interferences. And it is very durable because you can see that in this coaxial cable it has lots of coating like outer jacket, so it provides the insulation and the cable will be physically tough. And it is very easy to install, like because we can cut these coaxial cable using the crimpers and usually available tools. So it is very easy to install and it is very cost effective as compared to the fiber optical cables. And some of the disadvantages are it is bulk and weight, because you can see that as this coaxial cable is very thick, it is not that much possible to bend over the walls or the tight corners. So it is very not that much easy to handle with. And the fabrication is always difficult. It is like we won't be able to have some coaxial cable designed for our purposes. So we may have to buy the coaxial cable which is already available in the market. And one of the thing is it is known as unbalanced. That is, if we have to connect a dipole antenna to this coaxial cable, we have to use the structures like balun to convert this unbalanced current to the current in the dipole. So that is one of the disadvantage of this coaxial cable. So I hope you get some idea about the coaxial cable. Thank you.